This is video of our second experiment, which is about the specific gravity and absorption of fine aggregate. Starting with the purpose of the experiment, then the theory, apparatus needed, experimental procedure, the result, and lastly the discussion and conclusion for this experiment. The purpose of the experiment is to determine the specific gravity and absorption of fine aggregate. The specific gravity may be expressed as bulk specific gravity, bulk specific gravity SSD, or apparent specific gravity. Moving on to our theory of the experiment. The mass of oven dry sample in air will be labeled as A, then B will be the mass of mason jar filled with water, while C will be the mass of mason jar with aggregate and water to the calibration mark. And lastly, the mass of the saturated surface dry aggregate will be S. These are the formulas that will be used to find the result. The apparatus needed for this experiment will be the balance accurate to 0.01 kg, a mold in the form of a frustum of a cone, a temper having a mass of 340 plus minus 15 gram, an oven to dry the aggregates, a drying pan to be put in the oven, a mason jar with the lid, and a 0.6 mm sieve. This is our experimental procedures. First, place an empty water tank on the weight and pour the sieve fine aggregate until getting about 1 kg of fine aggregate. Then, immerse the fine aggregate sample with water for 24 plus minus 4 hours. Decant the excess water with care to avoid loss of fine aggregates. Then, spread the sample on a flat metal pan exposed under the sun and gently moving current of warm air, and stir frequently to cause homogeneous drying. If desired, mechanical aids such as tumbling or stirring may be used to help achieve the saturated surface dry condition. Continue this operation until the test specimen approaches a free-flowing condition. Hold the mold firmly on the metal pan with the large diameter down. Place a portion of the partially dry fine aggregate loosely in the mold by filling it to overflowing and heaping additional material above the top of the mold by holding it with the cupped fingers of the hand. Lightly tamp the fine aggregate into the mold with 25 light drops of the temper. Each drop should start about 5 mm above the top surface of the aggregate. Permit the temper to fall freely under gravitational attraction on each drop. Remove the loose sand from the base and lift the mold vertically. If the surface moisture is still present, the fine aggregate will retain the molded shape. If this is the case, allow the sand to dry and repeat steps 3, 4, 5, and 6 until the fine aggregate slumps slightly, indicating that it has reached a surface dry condition. Weight the empty beaker, then followed by the beaker filled with the tested saturated surface dry fine aggregate. The difference between those two will be recorded as S. For value B, we just need to weigh the mason jar that had fully filled with water until calibration mark together with its lid. That's how we get the value of B. For the next value, we immediately introduce the SSD aggregate into the mason jar partially filled with water. Then fill the mason jar with additional water to approximately 90% of the capacity. Roll, invert, and aggregate the pycnometer to eliminate all air bubbles. After that, fill the pycnometer with water to its calibrated capacity. Determine the total weight of the mason jar, fine aggregate, and water, and record it as C. Carefully work all of the sample into a drying pan, then place it in a 100 plus minus 10 degrees Celsius oven until it dries to a constant weight. For value A, we weight the oven dry aggregate with the drying pan, and then throw the aggregate away and clean the pan without any aggregate left on it. Calculate the difference and record this weight as value A. This is the result of our experiment. You can see the weight of each component on the table. The value of A, B, S, and C were obtained through this calculation. By using the formulas, we can get the result as shown on the table. Finally, we have reached the final part of our video, which is the discussion and conclusion. First, we had to decide the position of calibration mark on the mason jar. A horizontal line was drawn on the mason jar as calibration mark, and then fill the jar with water until the water level reached the mark and weighed. After the SSD fine aggregate was poured into the jar, we had to fill the jar with water again until the calibration mark. However, due to parallax error, we might view the mark at different angles, and the result would be affected. Second, there might have a little amount of fine aggregate be blown away since we exposed the aggregate at the outdoor to dry the aggregate under the sun until it reached surface dry condition. The result had slightly affected because it was not the actual weight of the SSD fine aggregate that it should be. In the process of moving the fine aggregate to another container, a little amount of fine aggregate might be lost too. The result shows that the bulk specific gravity in SSD state is larger than the bulk specific gravity in absolute dry state. Meanwhile, the apparent specific gravity was the largest. That's all for this video. See you next time.